Okay, so let me start. So my name is Mateusz Stefańczyk. As already Kirill has said, on daily basis, I'm working in the House of Angular as an Angular team leader. You can find me on the LinkedIn and Twitter. In House of Angular, as name suggests, we are just specializing in Angular development. Yeah, we provide ready-to-operate teams, but also we have a bunch of services like code audits and consulting. So if you're struggling with your existing solution, you can reach out to us, and for sure we'll find together some kind of the solution. Despite of being the software development company, we are also actively supporting a lot of communities and open source libraries. We are supporting NG Oslo, London, Berlin. We are also having our own community, which is called Angular.love. We are supporting open source projects like NGNeet. We are the bronze sponsor of Spectator, but also we are supporting NGRX, NX. So we are trying to be proactive in sponsoring and supporting the Angular communities. Okay, so going ahead, yeah, as I mentioned, we have our own community, which is called Angular.love. Initially, it was the blog for Angular lovers. Right now, we are also organizing some kind of the gatherings. Right now, we are starting again with series of the meetups. So I strongly encourage you to support and follow us on the social media. The list of the speakers is already there, so you can check it. We'll have a bunch of the GDEs there as well. Recently, also, we have rewritten our blog to be fully at the latest Angular. It's supporting the SSR. It's utilizing all kind of the latest features. It's fully open source. So if you're interested to taking a look actually into the code, see how we have utilized the signals, new control flow, or a bunch of the server-side rendering features, it's there. You can just go to our repository and see how it looks like. Also, you can provide us with the feedback, what's in your opinion can be improved, what's wrong, and so on. So as we already know, today we'll discuss testing strategies in the Angular. What are the possibilities, what Angular provides us by default, how we can extend from these defaults beyond using some external libraries and tools. We'll first try to answer the question why testing is important, what are the types of the testings. We'll take a look at the unit testing in the pure Angular. Then we'll take a look at the component harnesses. And finally, we will make some brief overview of the Cypress. I have chosen Cypress, but we could discuss their Playwright or Cypress, because both of them are very similar in terms of the API. Playwright is right now gaining quite more popularity, but yeah, both tools are very similar. And if you will be familiar with one of them, you will know how to play with the different one. Okay, so first of all, why the testing is important, and here I just extracted the 3 points. First of all, reliability. So every project, regardless of the size, must ensure that it's reliable. So without testing, we can be sure that new features wouldn't break existing functionality, and unit test and end-to-end testing help us prevent such kind of the problems. Also, if we already break something, but we have the test, it's easier for us to detect this kind of the bug. So if we have our test attached, for example, to the CI process, before we even merge it and let the tester QA team go over the feature, we will already know that probably we introduced the new bug or we break some kind of the business logic which leads to the bug. And also, it's help us to scale. In pretty big projects, it's not easy to code review everything, to protect and like see what the actual changes might break, because project is too big to know everything. And if you have it well covered with the tests, including the unit test or some other tests, we are much safer. Also, if you would like to refactor something, because you maybe have the tech debt, you have done in the past, or you are just migrating from one feature like RxJS to signal-based reactivity. If you have everything covered in scope of your test, it's easier, maybe not the easier because refactor is refactor, but it's safe in terms of refactoring the code. Yeah, so if you even break something, but you have everything well covered in terms of the test, you will know it quickly, and you will catch up it and will be able to fix your code. So those are the three main reasons probably we are writing the test and why we should writing the test. So what kind of the tests we distinguish? There is a picture of pretty well-known triangle of the test, and the first kind of the tests are the unit tests, and they are the most common type of the test, and this test should be the most common in scope of your application. You should have most of the things in scope of the unit test. They focus on the testing small isolated parts of your application, such as components, services, pipes, and they do it in the isolation. So it's testing done without testing interaction with the other parts of the system. So they are pretty fast and help us to catch bugs early. The second type of the test is integration test, and it's go one steps further in terms of the testing by testing how different small units work together. So, for example, testing a component along with real or mock service to ensure they integrate correctly, with underlying that it's more like mock service. And this is useful for catching issues in the way different parts of your application interact and talk to each other. And finally, there are end-to-end tests, which simulates the exactly user experience and how our app behave from the UI till the backend. So we are testing the entire path from browser to the server. And this test verify whether our application behave as expected from the user perspective. So, and those tests are not pretty common, and often those tests are misunderstood with the integration test, because we often write, for example, tests in the Cypress, and we are referring to them as end-to-end tests, but actually we provide mock API calls. So this is not actually the end-to-end testing because we are mocking the backend, but rather we are verifying whether our UI looks like and behave like we expect in the response we are assuming we will get. Yeah, so we are just providing this response by ourselves rather than we are actually working with real response. So those are the main three types of the test we can write in our project. There's even more tests like contract testing and so on, but those are the most common one. Okay, so first we'll discuss the unit testing in the Angular. This unit testing is built around a few core concepts, and by understanding these concepts, we'll be probably fluent, or will more or less understand how to write tests, maintain them, and verify the functionality of our code. So the first building block of unit testing in Angular is the testbed. And testbed is some kind of the foundation of unit testing in Angular. It simulates the Angular environment we are going to run our tests within. Yeah, so we are configure our components, services, dependencies for the testing purpose. The second building block are the fixtures, and the fixture is that already built environment which holds the instance of our component, representation of our component in the DOM, and we use it to interact with this component in some controlled setting. Other building block are the spice and mocks. So the spice and mocks are there for us to mimic the response or behavior of the particular provider to testing the particular thing in the isolation. So if you are testing our component, we would rather avoid actually hitting the HTTP client or just running some real service methods which will try to reach out outside of our application to the backend. That's why in most of our tests, we'll use HTTP client testing module, which is some kind of the mock over the HTTP client. And the same thing we can do in terms of our services. So let's say here we have our my service, and I can define the SPY that the get data should return string mock data. Otherwise, it's maybe we'll have some kind of dependency or run some kind of the logic with dependency, and our test will break, and we'll need to provide another dependencies, which might be annoying and completely not useful. And what's more, we are no more testing in isolation, but rather we are just doing some small integration tests because we are involving other parts to test of our component. Another part are lifecycle methods. And lifecycle methods are there to set up a test environment for our test and to run it each time we are running some kind of the test. The most famous and common one is before each. There is also after each. But to be honest, in our tests, we usually avoid using before each, and we are just creating our own method, which mimic the before each. So what it's actually doing, it's setting the testing environment for our, let's say, component. But instead of using before each, we're creating the method which accepts some kind of the options. And thanks to these options, for the specific test cases, we can define some custom scenario or some custom response for services that we can properly test what we are actually expecting. Yeah, so here with before each, and this scenario, our get data will always return the string mock data. But for example, you would like to test what happens if it's return some other string, and with before each, we don't have simply easy way to configure this setup. That's why we create our custom method, which will, for example, accept the response of get data as a parameter, and will set up the testing environment for us with these options. And the final one are expectations and measures. So those are there to verify whether end result is what we actually expected. Yeah, so if we have our test, we can write like expect and verify whether get data is actually mock data, or we can verify whether our service has been called one times or more times. If it's called once, then more, we will get an error. So we already know that we have done something wrong in our code. And this is how this simple test will look like in the single file. What is also important here to point out is that Angular unit testing by default have a few disadvantages, and one of them is boilerplate code. So setting the test bed for pretty complex scenario is extremely annoying and enforce on us a lot of boilerplate code to declare the components, inject services, provide the mocks to these services each time. And it might be annoying if you're just testing a few components which rely on exactly same service, and you need to provide mock for it. Also, it's not that easy to mock services and dependencies. This my scenario was pretty simple, but when you need to use this spy on for the methods and so on pretty often, and often without the more reason, only to avoid calling the specific method to run its logic, that might be extremely annoying. Also, the tests became verbose and hard to read. If we have larger projects, more complex test scenarios, it's hard to read how those other parts talk to each other, how they interact, and so on. And finally, it don't provide any user developer friendly API for testing DOM interactions and actually how our DOM looks like, and to have some streamlined API over DOM interactions. But what, for example, is the most important in component testing in terms of the Angular is what actually being displayed. Often developers focus on testing some, I don't know, logic, private methods, whether some methods in scope of another methods has been called X time and so on. But the crucial from the Angular component test perspective is what's actually being displayed in the DOM. And that's what we should focus and what we should mostly test. So on the front-end testing, we are just focusing on the front-end stuff and verifying whether what's being displayed is what we expect, because it's what user actually will see, yeah? So without the pretty smooth testing for the DOM, it's not a pleasure and it's not easy to verify our DOM. And that's why people are looking outside of the Angular, and there are some great alternatives, and one of them is Spectator. So Spectator is a powerful library with the great amount of utilities, and it's extremely simplified the way we are just setting our tests, mocking our dependencies, and that's the tool most of us and also we in the house of Angular are using for unit testing in Angular. So we can call it some kind of the abstraction over the testbed, which extremely simplify setting environment for our components and creating the mocks and playing with the DOM as well. So if we compare the boilerplate code, by the first look, we can already see it's much, much simpler. So to create simply the environment for testing the component, we need to use create component factory and provide the component, and all kind of the mocks will be automatically mocked if it's possible. So it simplifies us a lot of stuff. Also, if we take a look at the mocking, we can use auto mocks. So if we say, okay, I need to mock this specific service, but we are not interested in response, for example, from specific method, but we want to be able to call this method without executing it logic and going deep into its own dependencies. So we can use auto mocks by defining the mocks, and that's it. Spectator will take care of everything for us. It's not possible in the Angular. We will need to define the mock for get data method and just make it returning some dummy stupid data to have it mocked, or we'll need to create the spy over these methods, yeah, as I have done in my previous example. Also, the readability of the test is extremely easy. So it has a lot of built-in helpers, like the querying the elements and asserting the elements, whether they display the proper text and so on. So here is an example of querying the H1 element and verifying whether it has the proper text. It's simply scenario, but we are able to do it in the one line, and we have the dedicated assertion like to have text. So we already assume that it should be, for example, text, not a number, and so on. And there is like plenty of this kind of built-in utility assertions in compared to default Angular. Also, we have the smooth API for interacting with DOM, so clicking the button or just doing some other stuff like checking the checkboxes or verifying whether checkbox is already disabled or not. There are dedicated assertions for that. And by having this example with clicks, we simply call spectator click, and we provide the query selector for element we would like to click. And in compared to Angular, we already can see it's smoother and faster. And also, it has the better support for more advanced asynchronous scenarios. So here you can see the full example of simply testing in Angular when we have some asynchronous request involved or asynchronous method involved in the testing. So we can see how we have to play with that one. We need to manually trigger the lifecycle hook, trigger DOM update, waiting for task to be complete, and again, this entire testbed configuration. But simply in Spectator, it looks more or less like that. So we automatically trigger the ng on init and updates the view. We have more descriptive API, and as you can see, we can simply do it in much smaller amount of the code. So this is extremely simple example, but if we will take a look at the even more advanced scenarios, you will see even more benefits of Spectator. So I strongly encourage you to take a look at this library if you don't know it. And for me, it's definitely the must-have in terms of writing the unit testing in the Angular. Okay, but also Angular by default provide us something known as harnesses. And harnesses, Angular harnesses are kind of the testing abstraction over our components. So we can imagine that we are the creators of some UI library. Let's say we are creators of PrimeNG or Angular Material. We have the plenty of UI components which are used across of the multiple other parent components. And user, when testing these parent components, needs to interact with these UI components, and they always need to select the checkbox, select the first element from the select or from some list, and it's very repetitive code. And we would like developer to avoid like querying the entire components, entire DOM of our component, but we would rather like to expose them the class for testing, and that's what the Angular component harnesses are. So here we have the comparison of two scenarios, where the first one is the test case, where we have by ourselves find let's start what we want to test there. So we have some app component, and in scope of this app component, we have the select component, and we want to test scenario of selecting the first option, and the first option should be string Mateusz. So what we have to do in the first scenario, where we don't have the component harness, so this abstraction over the select component, we need to first find the select element inside of our child component, open this select element, find the select element options, and select this first option, yeah? And let's say like selecting the nth option is pretty common scenario, and we have like plenty of smart components which need to test what's happened when user select something. And the second scenario is where we created the component harnesses class over our select class. We expose this component harnesses class to our clients, so other developers, and we expose it with specific methods. So we already create an abstraction over opening the select and selecting the nth option. So what user need to do in his test case is only get this harness class and call methods on it, and pretty descriptive methods. So open select and select the first option. In this first scenario, if we assume that user has been looking for our select by the class, and in the future, we as an author of the UI library change the class names or something, his all tests will fail. If we do it in scope of the component harness, we have the full freedom of refactoring our components, but what we only need to ensure that the open select and select nth option is doing what it has been doing in the past. And all of the consumers of our UI components are pretty safe. And I give an example of some being the creator of UI libraries, but also a lot of us has probably in the project some component we are using across of multiple other components, and it's our own component. And we often need to repeatedly test same things, and we probably doing it manually as in the first scenario. So it's a great point and great place to create the component harness for exactly this widely used component. And how we are just, what are maybe the building blocks of these component harnesses in the Angular? Yeah, also here are some kind of the benefits, but I probably list of them already on the slide before. Yeah, so this reusability, so we can reuse exactly same logic across of the multiple components without repeating exactly same step again. Readability, so it's much better to read like open select and select nth option than I don't know, fixture, query, select options, get first, and so on in normal test case. And refactor freedom, yeah. So that's what I said. If we expose some testing API over our components, what we need to ensure is that these API methods will behave in exactly same manner, but we don't care. We can like refactor classes, names, structure of our components, add diff, remove diff, and so on, because we know no one is relying on these elements, but more people are relying on this harnesses class. So first building block is component harnesses class itself. It has a bunch of the methods, and the first one is host, and it returns as a promise for the host element of the corresponding component instance. Locator for, so here we can look for specific item in scope of this component. And we also can say that this element is optional, or locator for all when we look for the list of the elements matching the specific selector. So here is an example of creating the HOA, which stands from House of Angular checkbox harness. And as you can see, we need to extend the component harness class, and we need to define the host selector, which is the name of our, which is the selector of our component. And then using the locator for, we can look for the input, which is the representation of our checkbox, and provide some methods to interact with this input. Yeah, so we will have there like checkbox, uncheck checkbox, and we can also make some methods like is checked, is not checked, and so on and so on. And we'll do everything using this input, but this input is protected, might be even the private. So no one will have, from the external world, consumer will not have access to this HOA checkbox, but he will rather have access to this method to make it check or uncheck, to verify whether it's checked. And if even we in the future change this selector for this input from data-test selector input to something else, we are safe, yeah, as I said, because it's only for us and no one should rely on this attribute. So another one is test class elements, which provide us a bunch of the methods. And as you can see, these methods are pretty descriptive, like blur, clear, click, focus, hover, text, and so on. So here we have this testing element. It's our input, and we can like verify whether it's being disabled. So that's what I said. We created the method is disabled, and we expose it for the user, and based on that we verify whether is disabled is true or not. And the final one is the testbed harness environment class, and it's the class which we utilize to load our harness in scope of the Angular tests. So there is a loader. We can define where for this class our harness testbed should looks like. So by default, it might look at the component we are testing, but we might also want it to go even further, like document root loader, where it will look for the instance in the rooted at HTML document. Also, we can create a component harness for the fixture's root element directly using harness for fixture. So this is how we usually define the loader. So we provide the fixture in scope of which we should look for our harness. And finally, we are reaching the integration end-to-end testing in the Angular. And Angular had its own framework, which was the protractor. It was the tool for Angular testing, but it's being deprecated right now. And it's mostly due to lack of modern features. So as I said, there are already some more reliable tools, developer-friendly, more developer-friendly, with much more features than Protractor. Also, the Protractor itself had some maintenance complexity, so there was no space and time also. Like Angular had to also take care of another tool, which maybe they don't want it, so it became difficult. Also, it has pretty difficult dependencies like Selenium, WebDriver, Node.js, and also Angular-specific features. So based on this, Angular decided to deprecate Protractor and don't have to maintain it anymore, since we have like better alternatives. And those alternatives are Cypress or Playwright, as I said. For me, both of these tools are pretty similar and provide similar API. Of course, there are differences in the way that they're being run under the hood. Playwright right now is gaining more popularity due to the fact that it's have more recent features and being much often updated. Also, this tool has the big company under it because it's maintained by the Microsoft. Cypress don't have this kind of the support. So I see that right now a lot of developers are choosing the Playwright over the Cypress. But as I said at the very beginning, both of these tools are pretty similar, have exactly same way of thinking in terms of like creating the integration and end-to-end tests. So if you will be familiar with one of them, you will be fine, in my opinion. So let's take a look at the key features Cypress provides. The first one is time travel. So we can mimic and traveling in the time. Yeah. So we can say, let's move or wait 2 seconds, 1 second, and see what happened, how something looks like. It's easy to debugging. It's provide the great UI for developers, which we'll discuss later. It's also automatically waiting for commands and assertions, which might be also the promises. Can be used for the unit tests. We have the control over the network. We can take a look what happens in the network during our tests. We can verify what are the response. We can record the screenshots and videos of our test executions. So it's also useful in terms of the CI, because if something fails in your on your CI, you might get the screenshot or video recording of this particular test and see what actually went wrong, for example. And also have ability to test on multiple browsers. So if you need to support some UI stuff on the multiple browsers, it might be great to do it using Cypress. So what are the key features? The first one is simplicity of getting the elements by the various query selectors, so we can simply get it by the name of the element and call directly the methods on it. Also, we can do it in the asynchronous manner, so we can run the promise over getting the button and execute some specific code when we are sure that this button is already visible and accessible for us. The basic commands are get for getting the specific element, as I showed you, visit for opening the specific route on our application, click for clicking, as it says, and the equal to comparing whether something being equal. Also, we can selecting the items by the ID, by the class, or just specific attribute. So we have the big flexibility there. You can see some specific data CI attribute. And this is an attribute Cypress is recommending us to assigning to elements we are going to test. And as I said, in terms of the component harnesses, it's provide us also here some kind of the how to say safeness. I don't know how to call it properly, but we are safe in terms of interacting with our code. We are safe that we are not depending on the class, which some other developer might come and just rename or remove because it's no more needed. So if someone already see data-ci, he already knows in the project, okay, this is dedicated for testing purpose, and I shouldn't touch it. And also what we are doing in our projects, we are not calling it data-ci, but we are calling it data test. So we already know that this attribute is for the test, and we also using it in scope of the unit test and the integration test. And we have pretty flexible name being data test, so we are not referring to any tool like data CI is strictly referring to Cypress. There is a bunch of the great actions like create click, double click, right click, type clear, check, unchecked, select trigger, select file. So those are the actions which we can mimic in scope of our text to mimic the expected behavior of the user, like right clicking, whether something being visible when user will right click and so on. So all of these actions are extremely useful and provide a great developer experience in terms of the testing. And those are also then actions we, for example, lack by default in the Angular. Yeah. So that's why I said we are looking for some outside tooling, like for example, Spectator, which by default provide us with click or check, verify whether something is checked. So those actions actually are something what speed ups our testing development. There are also great assertions, so we can write should and just then by the string say what it actually should. So whether it should have length equal 3 or should not have class disabled and should have value for bus. So these assertions are extremely flexible and provide us great developer experience in a way of asserting our testing scenario. Here again, we can even combine a lot of these assertions together. Yeah. So here, for example, whether something should not exist, and here is a scenario when we combine multiple assertions together. So first we verify whether it's have the class active, whether it's have the attribute ref, and whether this attribute includes the cypress.io. So yeah, extremely powerful. We can also define the aliases for pretty repetitive stuff. So we know that we often need to refer, for example, to the user JSON. So we can create an alias over this fixture and then refer to it as a users. Yeah. So for example, we are just testing the user page and we don't want to do repetitively CI fixtures user.json. So we define it as users, and then utilizing ci.get, we can refer to this alias and run specific logic when the users are already accessible for us. So what are the best practices in terms of the testing in Cypress? And also, as I said, it's for sure applied to Playwright as well. So creating the sharing functions and repeatable logic. So we can easily share repeatable code, verifying same things, or just getting the same things in a few places. Using the data dash selectors, that's what I already mentioned. We should avoid visiting third-party sites with CI visit. We should rather move only across of our application. Tests should be independent. We should use multiple assertions instead of creating each of these assertions separately. If we can like make multiple of them in the single place, it's a good practice. We should avoid, but what I mean like multiple assertions against one thing, because we shouldn't try to test too much things in the single test scenario. Like the single test scenario should referring for single test of the functionality or something we want to test, but we shouldn't avoid to create like extremely big test scenarios when we are just validating 3 or 4 separate cases in the single test. So that's not what I mean there by using multiple assertions. We should avoid using ci.wait, because if you will use it too often, it will decline the speed of our test, and it might be pretty slow on the CI if we will have like multiple ci.wait in our test cases. We should avoid using if statements in the test. So that's what I said a while ago. So testing 2 different paths, this should be separate tests. Yeah, so don't create 2 big tests. Don't try to fit too much logic into single test. Rather try to make it separate. Okay, let me know if you would like. Okay, that's something I had in mind, but it shouldn't be there. Okay, and there is like Cypress GUI. That's what I mentioned, that they have the great UI for testing, and this is accessible for us whenever we are running our test. It's in the Chromium, and what we can see there, we can see how many tests passed or failed, and how fast this test took to run. So on this example, we can see that 4 tests were successful, 2 went wrong. Yeah, so they actually failed, and it takes 4 seconds. We can see URL preview, so the current URL of our application where we actually being. We can see the viewport size on which we are just testing, so we can test responsive layouts. We have the real preview of our application. So if our test being run and we are just actively like clicking the buttons or just expanding this accordion, we will see it in the real time, what's going on in our application. And here we have also command log. So every command log as it executes, so being highlighted, we can see what kind of the interaction with our elements being done. So we can see that it's get the new to-do or to-do list, it's expect label to contain something. So it's extremely easy to track what's going on over the entire way the test being run, and we can then easily, based on these tracks and logs, debug our test. Also, yeah, here is an example of how this looks like in details. So we can see what being validated and what kind of the actions has been done before. Okay, and that's everything I have prepared for testing strategies in Angular. So as I mentioned, we should try and focus on the unit test as a main purpose. What I will do right now, I will always support myself with Spectator. If I will have pretty reusable component, I will create a harness for it. And going to integration tests, we should choose between Cypress and Playwright.